Alright, so we have this problem with cats and dogs, and we have to figure out what their ages are. So this is the applicable part of that paragraph that tells us exactly what it is we want to do. And at the end it says they want to write a program that will tell us the human year equivalent for the pet. So we know that human years is what we want to output, and we have to calculate that. So we'll go ahead and copy this and paste it up on the top. Okay, well, how are we going to calculate those human years? Well, what we're going to do is we need to know the animal years and multiply it by the year rate. Alright, so depending on what kind of animal it is and whether they stay inside or outside, we're going to come up with the year rate, and we're going to multiply that by the animal years. And then we have to ask ourselves, well, where are we going to get the animal years from? Is that something that we're going to calculate, something that is going to be provided to us every time we run the program, or something that never changes? And we know that the animal years is something we're going to ask the user when they come in. How old is your animal? And that's going to show how many years that animal has been alive. So we're going to have to ask that question. So that's going to be input. So I go ahead and copy it, and I paste it into the input section. So I'm going to be asking them what the animal years are. And then the year rate is something that I'm going to have to decide upon. Now the year rate depends on whether they're an inside cat or inside dog or outside. So what I'm going to have to do is I'm going to go ahead and put the rates up there. So I'm going to say, well, inside cat rate, and we see from here that it's equal to 7. Alright, that's what it tells us up here. And then we have an outside cat rate, and that's equal to 8. And then we have an inside dog rate, and that's equal to 6. And we have an outside dog rate, and that's going to be equal to 7. And you might be wondering, well, why am I putting that up here in the assumptions? Assumptions are things that allow us to figure out the scope of the problem, but they're also where we put our constants. So every time we run the program, we're not going to have to ask them all what all the different rates are. That's going to stay the same. But we can see that through another study, maybe a year from now, might find out that these numbers are not quite accurate, and we'll have to change these numbers. So that's why we go ahead and we assign these values to these places in memory, and then if later on a rate comes, study comes out and it says, well, outside dogs, they really should be a multiplier of 10, then we'd come in here and just change this, and we wouldn't have to change anything else in our program. Alright, so we have the different rates. We're going to figure out the year rate, and the year rate all depends on the type of animal and how long, whether they live inside or outside. So next thing we're going to have to do is make a decision. I'm going to say that, well, if the animal equals cat, then what are we going to do? What is the rate? Well, the rate is one of two things. It all depends whether it's inside or outside. So what we're going to have to do is nest the if. We're going to say, well, if it's a cat, then I'm going to have to find out is if its living equals inside. Then we'll do this. And then we'll say that the animal years is equal to, since that's an inside cat rate. And I'm just going to go ahead and copy and paste this because then it's consistent. Okay, so now we know we've gotten 1 down, 3 to go. And we're going to say, well, what if it's not living inside? Well, that would be an else. And if it's not living inside, it's still a cat. Then we're going to, for consistency's sake, I'm going to copy this, paste it down here, and this is going to be the outside cat rate. So now we have cats done. What if it's a dog? A dog is an else. If this is not true, that means that's what the else comes in. Then we're going to have to figure out whether it's inside or it's outside. Here's another chance for us to use copying and pasting, make our job a little bit easier. Since we were consistent in our namings, whoops, I can simply paste this in and change everything that says cat to dog. And I don't have to do anything else because these are references to these up here. And since they're now all consistent, whether it's a cat or it's a dog or it's inside or outside, we have now figured out everything. We have figured out all the places where that's not right. This is not animal years equals. This is the year rate. Sorry about that. Okay, so the year rate is what we're trying to find out. Animal years is something that's provided to us. All right, so we're going to take that year rate and copy it and paste it. Now it makes a lot more sense. All right, so now we know the animal years comes from an input, and the year rate is what we were trying to figure out. So sorry if I confused you. Once it figures out the year rate, then we can do this math, and then we can do this output. So actually, we have now finished the problem, except for additional assumptions. And one thing we can do is only 2 types of animals. And we can ask our user, and they say, oh, no, sometimes we also get squirrels. And I say, okay, well, what's the inside-outside rate for squirrels? They have to tell us. So I asked that question just to ensure that I, as a programmer, have solved this problem, and there's no other things out there. Only 2 living arrangements. Again, I said, well, what happens if it's 50-50? Oh, well, 50-50, then it gives me some more numbers. So I don't want to do that. And then only 1 animal at a time. And I can say, okay, so only 1 animal. Oh, no, well, if Susie brings in 2 different kinds of animals, then we're going to have to do both of those, which means we'd have to add different inputs, and we would know that our solution was not right. But they say yes, 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 and we know that our solution is perfect.